Today we are extending the functionality of a JavaScript array object, finding out the largest number that occurs the most number of times in an array, and we are encoding vowels with numbers. And in the end, I show you a bonus solution in which I implement a hungry sequence. Hello world, and this is versus Codewars. Here, we are extending JavaScript's array object with several useful functions: square, cube, average, sum, even, and odd. Let's go ahead and get started here. We extend the functionality of an object in JavaScript by doing this: array.prototype, and then the name of our function, in this case, square. Now, since we'll be accessing the this object in this function, we can't use ES6's arrow syntax. We'll have to use the regular function syntax here. Alright, the first function we're extending here is the squared function, which returns the elements of the array squared. And we can do that with the array's map method. So we'll go ahead and do this. Return this.map. Pass in our element into the predicate function. And then we'll just return element times element. Let's go ahead and test this out here, see what it looks like. Console.log 1, 2, 3, 4, 5 dot square. Be that in a node here, array helpers. And as you can see, we have our numbers here squared. Alright, the next function we need to extend here does the same thing as this, but only returns the elements cubed. Array.prototype.cube equals function. And we'll do exactly the same thing we did with the square function up above here. Only we'll just do element times element times element. We'll test that out and see what that looks like here. Console.log 1, 2, 3, 4, 5 dot cube. Be that in the node. And as you can see, we have the elements of our array cubed. Alright, the next one I want to extend here is called sum. Array.prototype.sum equals function. Now, this function will use the array's reduce function to calculate the sum of the elements of the array. We'll do like this. Return this.reduce. Pass in our accumulator and a value, and return ec plus value. By doing this, we calculate the sum of the elements of the array. The next function we need to extend here is called average. And this function will do the same as the sum function here, but only it'll divide that sum by the number of elements in the array to get the average value of the elements. That being said, we need to account for instances in which the length of the array is 0. If this dot length is 0, we want to return not a number. Return number.nan. We don't want to be dealing with any divide by 0 issues here. Alright, we'll do the same thing we did with the sum function above. Return this.reduce ec value, ec plus a value. But we'll take the return value of this and divide it by the length of the array, this.length. In so doing, we get the average of the array's elements. Alright, the next function we need to extend is called array.prototype.even. And this function will return an array of only the even number elements of the parent array. And we can do this with the filter. No, we can do this with the filter method, excuse me. Return this.filter. Pass in the element into the predicate function. And we'll return true if element modulo 2, that is the remainder of element divided by 2, is 0. And then the final function we need to extend is called odd. And this will do the same thing we did with even, only check to see if element modulo 2 is not equal to 0. This should all be good, so let's go ahead and pop this into Codewars here. And try to submit it. And we are good. When using .prototype to extend the functionality of JavaScript objects, you need to use the regular function syntax instead of ES6's arrow function syntax. The reason for this is you need to access the object's this keyword, and you can only do that with the regular function syntax. If you write your prototype extension functions with the arrow function syntax and you attempt to use the this keyword therein, you'll get the this context of the parent scope or the global scope, and you do not want that. Given an array of numbers, our goal here is to return the number in the array that occurs most frequently. In the case of a tie, return the largest value. Alright, let's go ahead and get started here. What we can go ahead and do here is... Alright, I think I'll try creating an object to cache the number of occurrences of the numbers in our array. Const occurrences equals an empty object. Go ahead and iterate through the numbers of our array here. For each number what we'll go ahead and do here is occurrences at number equals if the number in that object is undefined, we'll go ahead and set that to 1. Occurrences number 1 or occurrences number +1. Let's go ahead and console.log that and see what that looks like. Console.log occurrences. Feed that in the node here. And here we have an object here which shows how many times each number in our array shows up. Now from this we need to determine which number occurs the most. And I have a feeling we can do that by doing this. Object.keys occurrences .sort A, B, and we return occurrences at B minus occurrences at A. Go ahead and console.log that and see what that looks like. And if done correctly, we should have the number that occurs the most as the first element of the array. Now, in the event of a tie in which two numbers occur the same number of times in the array, we need to sort this again such that the largest number appears first. First, let's go ahead and return what we've got here first. So I'm just going to go ahead and detab this once and put this in a variable const sorted. I'm just going to go ahead and hit return a parse int sorted at 0. I'm going to go ahead and try pasting this into the Codewars here just to see what that looks like, see how the test will behave with this. And sure enough, got a little bit of a problem here. Twelve, 8, 12. Yep, sure enough, we're going to need to sort this again such that the largest of the tied values appears first. Sort a, once again, A, B. We're going to pass in B minus A. We'll feed this into Codewars and see what that looks like. Try submitting it. And okay. I'm gonna run this array through our own local test here. And get rid of this sort here. Yeah, as you can see here, 12 and 10 occur the same number of times here. So since 12 is larger than 10, we need to return 12 instead of 10. All right, let's go ahead and feed this array into our local test here. This needs to return 12. So I'm going to go ahead and hit console.log sorted. All right, what I think we'll do here is filter out any elements of the array that occur a fewer number of times than the ones with our highest occurrences. Filter elements. No, we do that before the sort here. No. Occurrences at element is equal to occurrences at A. Okay, yep. And element 0. Element 0 should be at least one of the elements that occurs most in the numbers array. Maybe not. Let's try that again. All right, I have another idea here. We'll come back to this in a second. Keep track of the highest of occurrence of any one number in our array. Const highest occurrence. Maybe not. Yeah, const highest occurrence is a 0. And in our for each method function here, if occurrences at number is greater than highest occurrence, we'll go ahead and set that highest occurrence to occurrences at a number. Let's go ahead and console.log that and see what that looks like here. Console.log highest occurrence. Whoops. Yeah, can't forget the parentheses here. Assignment to yep, this needs to be let. And it should print out how many times the element in the array that occurs most in the array has occurred. In this case, 3. And we can go ahead and use that in a filter function. First, let's go ahead and map. As you can see, we have strings here. These need to be numbers. Parse int element. Next, we'll go ahead and actually see what that looks like here. And we should have numbers here. Finally, let's go ahead and hit dot fill. Actually, no, this actually needs to be a string. I'm gonna disregard that. Filter element. What I think we can do here is return true if occurrences at element is equal to highest occurrence. We'll go ahead and log that and see what that looks like, and we should only have 10 and 12. And from here we should go ahead and hit sort a b parse int b minus parse int a. And we'll just go ahead and return sorted at 0. We will need to parse that as an int anyway. Alright, let's run that through Codewars and see what that looks like. Try submitting it. And we are good. Here is another instance of me using a cache to keep track of the number of occurrences of a number in an array. and also a number to keep track of which element in the array had the highest number of occurrences. In addition, I had an unnecessary sort in this Kata solution. I could have just done the sorting after filtering out any elements in the array that had a fewer number of occurrences than the element with the highest number of occurrences. Here are two functions. The first takes a string and replaces all of the lowercase vowels in that string with numbers according to this pattern right here. 1 for A, 2 for E, 3 for I, 4 for O, and 5 for U. And the second function will take the encoded string and decode it back into the original string. As you can see, I have the string hello here. We're going to go ahead and encode it, and then decode it, and then see if the strings match in this console.log here. Let's go ahead and get started. First, we're going to need a global array of our lowercase vowels. Equals A, E, I, O, and U. Alright, in our encode function, we're going to go ahead and run this through a regular expression. We're going to go ahead and do this. Return str.replace. We're going to go ahead and set up our regular expression here. And we're going to group our A, E, I, O, U right here. And we're going to make it a global regular expression. Now, instead of specifying a string to replace our regular expression matches with, we can instead use a function, the return value of which will be the string to replace it with. And we can go ahead and do that like this. Char. And we can go ahead and console.log our char here, see what that looks like. Console.log char. And just place that with a blank string for now. Feed that into Node. And we'll see what that looks like. And as you can see, it prints out each of the chars that match our regular expression right here. And by the way, it's... Alright, what we can go ahead and do here is return vowels dot index of char. We're going to run that through Node here, and we should have H1LL3, which is not what we were expecting here. Maybe just add a +1 to that here. H2LL4. Alright, with that being said, let's go ahead and write out our decode function here. And we'll go ahead and do return str.replace. Likewise, we'll go ahead and use a regular expression of 1, 2, 3, 4, 5. And we'll do another replace function right here. We'll take the char and return vowels dot at. Vowels at, excuse me. And I think we'll do try parse int char. Feed that through Node, and as you can see, we've got a little bit of a problem here. Try subtracting 1. Yep. And we got our encoded string here, H2LL4, and our decoded string, hello. Let's go ahead and feed this into Codewars here, see what that looks like. And let's try to submit it. And we are good. The second argument of the string objects replace method does not have to be a string that you want to replace certain sequences of characters with. It can also be a function that takes that sequence of characters as an argument, and you have more fine-grained control of what you want to replace that sequence of characters with, because you can use that function to work with that sequence of characters. This can be particularly powerful, especially when you're replacing multiple sequences of characters in a string using a regular expression as the first parameter in that replace method. Here is a bonus kata. Here we are calculating a hungry sequence of a given number of numbers. A sequence of integers is hungry if and only if a. its elements are in increasing order, that is, given indices I and j where I is less than j, the element at I is less than the element of j. B. for any two indices I and j where I is less than j, the element at j must not be divisible by the element at I. Alright, let's go ahead and get started here. We're going to start with an array containing our results. And that array is going to be pre-populated with a 1. We're going to go ahead and keep track of a current number, which will change during the coming while loop. And we're going to set this at 2. We're going to go ahead and return our results array. And we're going to do this. While results.length is less than num. And what we're going to go ahead and do here is results, and we're going to do a little spread operation here. Results.filter number. We're going to open this function up. We're going to come back to this later here. And for the last element, we're going to do our current. And we're going to go ahead and increment our current at the end of the while loop. And what we're going to go ahead and do in this filter function here is filter the number out if current modulo. We're going to go ahead and make use of that third argument here, which is the array being worked on, arr at. Well, actually, we don't need to do any of that. We just have the number here. If current modulo number is not 0, because if current modulo number returns 0, that means current is divisible by number, and such elements cannot be in the array in a hungry sequence. Let's go ahead and try this. I have an array of numbers here. We'll run through this hungry sequence method here, and we'll get the hungry sequences of each of these numbers. Let's try and see what this looks like. Node hungry. And we have an error. Assignment to a constant. Yep, this needs to be let, because we are replacing this array with a new array. And if all of this is done correctly, we'll note that none of the numbers here are divisible by any of the numbers before them. Let's go ahead and pop this into Codewars and see what this looks like. It's important to note that if there are multiple solutions, any solution will do. So this should work. Let's try submitting it. And we are good. I love working out problems in my head, and I thought I would show you what I came up with in this bonus kata solution. You can do what I did here, or what you could go ahead and do instead is spread out a new array with the given number of elements in the hungry sequence, and then run that through map by passing in the index of each element in the array, taking the number of elements in that array and adding that index to get the same results. I love finding better ways to do things. And that will do it for this episode of Versus Codewars. If you liked the video or you learned something new, feel free to drop a like on this video and subscribe to my channel to see me take on more coding challenges on Codewars. As always, if there's anything I can do to improve my code for the better, feel free to make suggestions in the comments section below. I hope you have a wonderful day, and I'll see you on the next episode of Versus Codewars.